Hello again. Great to be at 20th Anniversary Tech Live, of course. That was awesome last night, Fred. Thank you for having us all to the party last night. That was a lovely event. So let me tell you a little bit about what we're going to talk about with Hammerspace today. First, I would like to introduce Brian, who Fred already introduced. We'll be going back and forth in the conversation, keep things dynamic and interesting. But before we get too far in, Ryan and Mark are new at Hammerspace. They joined in the last month, essentially, to be our EMEA managers. So not just UK, even though they're both based here, but leading our Europe strategy. So what I would like to do is just take a minute for Mark to say, or for Ryan and Mark to say hello and talk just a little bit about our EMEA strategy. As a slight introduction, about 34% of Hammerspace's revenue comes through Europe. Most of our company customers are global, though, in some way, shape, or form. For example, Mathematics Studios was the most recent customer case study we released. They're based in France, however, they're taking in projects globally, and the reason why they like Hammerspace is maybe they're a visual effects studio. They want to take on a project maybe for Netflix or DreamWorks in the US. They can take the project, but then use French resources, French cloud infrastructure, French tax credits to bring the business into France. So you see with Hammerspace in a lot of these cases, Epic Games, companies like that who probably are running infrastructure and certainly clouds. I think Epic is up to 14 different countries of cloud regions that they're using for Hammerspace. But they're a European-based company. So those are kind of how we think about Europe, and most of our customers, we're focusing on those global customers who have a global problem as our primary focus as a company. But of course, with the business entities and many of the data centers and clouds here in Europe, Europe is a really big focus for us. So maybe just you could take a minute, Ryan, talk a little bit why you joined.
Super, thanks, Molly. Good morning, everyone. So yes, as Molly says, Ryan Taylor, been with Hammerspace, as she mentioned, for a few weeks now. I think just by introduction, it was something I've been looking at in the market for quite some time, and in speaking to a lot of end users, everybody is looking, especially globalization of data, hybrid type of cloud. And then I think what Hammerspace offered, which was really attractive, is something more than storage. So data orchestration, intelligent placement of data wherever you need it, was something that was really, really appealing from what I could see, and that's echoed by what customers are looking for. So I think it's a very exciting session today that Brian's going to lead us through technically. And then just by way of how we go to market and the strategy behind that, everything is indirect, so we will be working exclusively with partners through distribution, and then of course your value-added resellers. So that's an exciting time, and lovely to meet you all. Thank you.
Hello everybody, my name's Mark Lucas. I'm working as the EMEA Systems Engineering Director. I'm a technology person at heart. One of the key things that I really loved and attracted me about Hammerspace was its pure understanding and innovation around data placement of data, orchestration of data, and the ability to take data into a managed cloud platform on a global basis. One of the other key things I think is really exciting about this as well is the ability to report, audit, and look at your data in an intelligent way, and then make decisions and placements of that data in locations that data is needed. So a lot of people have been doing this historically, the scripting and complexity, and using a multitude of different products. For me, and why I thought Hammerspace was unique, was around our orchestration piece, and you'll hear a lot more about that today. And what I'm hearing from customers, they want simplicity in their workloads. Anyway, lovely to meet you all. Thank you very much.
So super excited to have an experienced team. I'm not going to talk about where they came from, but if you looked at their LinkedIn, it's interesting the places that people are coming from to join Hammerspace. There's a lot of innovative companies that there's a lot of allure around Hammerspace right now. We are growing very fast. We plan in the next 6 months to triple the number of sales teams that we have in market around the world. We are growing like wildfire to the point that our biggest bottleneck in go-to-market right now is continuing to train pre-sales, customer support, technical architects for the amount of demand that there is for Hammerspace. So we're, of course, hiring and training as fast as we can, bringing folks in like Mark, who knows the industry well, helps, you're already well along in a lot of the knowledge space. So things are really moving quickly with Hammerspace. What I want to talk about today, I will be dropping over, yes?
Quick question with that.
Please.
Do you have any channel sales and channel partners?
Yes. So we're 100% channel with the exception of I think we have 2 accounts we had to take direct because, they are fancy accounts who demand that. But our go-to-market is 100% channel. Here in Europe, we have, or in the UK, we have Titan Distribution as a distribution partner. We also use Climb at a more European level. Titan's a bit European, but Climb is more so. And we have, gosh, I won't get the number right. We have about 15 or so active partners here in the UK focusing on different markets. So we don't want channel saturation, but we do want channel partners who know financial services, who know autonomous vehicles and manufacturing, who know media and entertainment. So we try to cover each of the markets with at least 1 or 2 channel partners.
And so the skills training, this is internal to you, not to your partner base, is that right?
It's both.
It's both.
Yep.
We actually, when we bring on board any new channel partner, we try and assess their capabilities and how they represent themselves in the market as well. We have simple sales level training for those sort of lead gen kind of partners. For folks that want to get in a little bit deeper and own more of the solution design, there's sort of an intermediate solution architecture training. And for those that really want to go all out, there's a full-on dig under the covers for several hours and get dirty. So it's really up to the partner to decide how far down the rabbit hole they want to go, but we can help them all the way.
And Brian is, I believe this is accurate, responsible for creating the technical training for our partners. That's one of the things that he does is we need to scale our partners' technical skill sets, not just to pre-sell and size, but to deploy and optimize. We'll be launching our community program, our developer community, in the next quarter or 2. And so there's a lot to our automation and objectives of data placement that you can write something called an objective, which is a software script that says, I have this business objective that my data of this type always has a certain performance attribute, or my data of this type has to be subject to GDPR and can't cross country boundaries, things like that, rules of where your data can go. And that's written in software. And one of the big things we see as an advantage to our customers is sharing those software-based objectives that have already been written so others can use them or modify them, that type of thing. So Brian's very involved in the training of partners and will be involved as we get the developer community going. Yeah. In case you didn't know, you will be.
I got promoted.
Any other questions, just briefly? We'll talk a little bit more about our business updates towards the end, but I just wanted to make sure you'd met the team and had,
Ignace is the Y2T distribution for a small company.
Yeah, sure. So I've wondered that honestly myself sometimes, but what we find is that when you have specialized markets, sometimes a specialized distributor can help to scale enablement, access, training programs, because we're still quite small as a company. And they have a lot of the infrastructure, the training, the communications already in place that we can take advantage of. The other piece to me is that these vertically focused distributors in particular know all the customers, and they know, okay, in the AI environment for this customer, that's this team and this partner, this reseller. But in the IT, it's another reseller, so they can kind of help navigate which reseller in which workload in each company. I don't know if anybody on the channel side has any other comments to that. That's how I perceive it.
Yeah, that's
Good enough.
I wouldn't say it too terribly differently.
Okay. So that is a big piece. We're growing fast. As far as revenue, it was about a double, just under 200% growth year over year over the last 12 months. It will be about 400% growth next year. We're scaling our company, but we're having to scale all of our operations as quickly as possible. And we're finding that these value-added distributors, not just the box pushers, but a value-added distributor is helping us scale, is kind of a summary of all the things which we need to do. Yes?
Please, yes. Marty, about you tell me what is the balance between the new business and the renewal?
That's a good question, and now I know who put the questions in. That came in. Aha, you gave yourself away. So as far as new business versus renewals, we've been general availability of our technology for about 2 years, to give you a feel. So there's a lot of new business and new logos to bring into the company. I mean, we've just barely scratched the surface on new logos. So it's pretty balanced, about 50-50, because now, if you asked me that question a year ago, it was all new logos. But now we're at that point where we've been deployed in a customer long enough that they're coming up on renewals and expansions. And the way we go into most customers is they have a specific problem which their existing IT strategy doesn't meet. Maybe they have, like Blue Origin, we'll talk a little bit more about them later. Blue Origin is Jeff Bezos' rocket company. They were all data center based, and given that Jeff Bezos owns them, of course, they're supposed to be using some cloud. They didn't have a good technology to connect multiple data centers and the cloud because they couldn't have those be isolated workflows. So they were very happy with their Cumulo storage in each data center. It was doing what it needed to do, but it didn't have the ability to connect active workloads and the cloud together. So they brought us in for the data sets which needed to be collaborated on, telemetry data, failure data, and research data, all in a single HPC processing center. That's what they brought Hammerspace in for. But they also now have other things that they're doing. They're bringing other workloads onto us, and that's the expansion opportunity, is not so much collaboration, but an HPC environment that's just a local data center, high performance storage. So it's about 50-50 at this point, and probably will remain about that. There's a lot of growth opportunity in the customers we're already in, so I expect a lot more expansion.
Yeah, the question was, also to understand your churn rates.
Mm-hmm.
Right, so.
Yeah, and I mean, if you think about our sales cycle, we're still new enough, we don't know exactly, but it's probably kind of in the 9 to 14 months range sales cycle. And we've only been selling now for 2 years, so we're trying to focus on where do we offer the most benefit, which types of accounts to focus on. So we have a focus on growing our customers who are kind of in the $1 million to $10 million range of revenue opportunity. Doesn't mean other customers don't need us, they do. It's just we have to focus our efforts. So we're focusing right now on what you would kind of consider Fortune 100, 200 were most of our efforts, and getting in a location and expanding as quick as possible. It's how we're prioritizing our work right now. So if I talked to you a year ago, which I did, talked to a bunch of you a year ago, we were fairly vertical focused, and we've switched to that because every industry has a need for Hammerspace. And now we're looking at the types of companies and workloads in the companies that are large enough to really take advantage of our technology. So we've switched to more like an account-based selling motion instead of vertical.
Yeah, and the only other thing I'd add to that is if you kind of look at the value proposition of expanding, the edges of a customer's workflow where Hammerspace can apply. You start looking at where we come in at a singular problem statement as our first introduction to the customer. And then over time, they start allowing us to move further and further into that pipeline or that workflow and take over more and more of it over time. So it's also an evolution. That traditional land and expand does not just mean add more capacity. It means own a little bit more of the business value of that pipeline.
So I'll be sharing with the A3 team a press release, which we're going to put out tomorrow, related to our AI reference architectures. But I wanted to talk about it with you all here today first. So this is the first time we've really talked about what we're doing in AI. It's super buzzwordy, everyone's talking about it. We have not jumped into that just because it was too noisy of a market. However, we have some really interesting wins, which we want to share what we're doing in the AI market. And we'll follow on with the press release, which Fred and Lisa and the team will share out. But first, let me just talk a little bit about what is a Hammerspace. This is fun. This will warm you up. It will explain why I gave you superhero capes and your little red bags there. So a Hammerspace, and this is the origin story of our company and the name, is an extra dimensional storage area that allows objects to seemingly be produced out of thin air. It comes from Japanese anime and the comic industry, and it's a very well-known term if you're interested in kind of a Comic-Con person. So in the latest Spideyverse, they talk about his Hammerspace, and it's that place where he has this tiny pocket that's flat on his little superhero suit, and all of a sudden a big mallet comes out, and large things are produced seemingly from thin air. There's an analog, of course, to Hammerspace on what we do with this, but you'll see us more and more doing superhero fun things. We won Best Technology at the Supercomputing Conference in Denver earlier this week. You'll see photos of us around with superheroes in all of our imagery, and we're really leaning in on kind of what this Hammerspace is and how it applies to data. So it's also, if you think about it, there's a relationship to hyperspace, and you'll hear us talking about we overcome data gravity, the previously held physical notions of things like Moore's Law, data gravity have been overcome with technology that's available today. Hammerspace is one of those key technologies. So there's also that analog, not just to comics, but to hyperspace and the ability to store and retrieve things while they're in motion, faster than the speed of light. So that's a little bit about Hammerspace. And so what was once science fiction and comics and movies is now a reality, and it is for your data. And we're going to talk a little bit more about the innovation today of what Hammerspace has done in our technology. These are slides we've never really presented as sessions, so hopefully this is new to all of you. It's what we're doing in the standards committees. So our CTO is a gentleman named Trond Myklebust.
Don't look at me, I'm from Southeast Texas.
He's Norwegian, so anybody who can say
I
this
will
properly.
mispronounce it all the time.
He's one of Linus's Linux kernel maintainers. He's worked with him directly for 25 years. He's the NFS kernel maintainer. He's our CTO. We're doing a lot of work within the Linux community, which is some of the pieces that Brian will talk about on how we're driving this into standards. Things like SNIA, which I'm a huge SNIA advocate, and SCSI Trades Association being here is lovely. We're actually trying to figure out a way to get Kioxia to embed NFS in an Ethernet SSD. So some of this is the technology track stuff that we're covering in those groups that we figured you would all find interesting instead of just marketing slides. So I'm going to do one more analogy and then we'll get technical. So if you don't totally understand the benefit of Hammerspace, here's the best, simplest analogy. It used to be when you wanted to back up your iPhone or your phone or your computer, you had a hard drive, you had a FireWire box, something like that. And all your data was stored in that. And now we have these iPhones that carry our data, they access our files. I mean, I can check in and run a Hammerspace demo on it. A lot has happened in the consumer space with embedding a lot of technology in a small device. But the data preservation piece was, I think, one of the biggest things that was really amazing in the consumer space of, I take all my pictures, the ones I took downstairs of the swimming pool this morning, I can access through my Mac, I can access them on my phone, my husband can see them at home through some kind of Google share, it's Mac tools, Apple tools. And the idea of real-time sharing of content and preservation was made possible as iOS started to make it where you had data orchestrated across devices, and you don't need to know the infrastructure. I truly do not know where my iPhotos are stored. I don't care where they're stored. What I care about is I have real-time access to them on the devices and with the people who I've given access to, and that's orchestrated for you.
Shouldn't you care about where they're stored? Because if you take a photograph of something that has intellectual property rights attached to it, the law may say you can only store this stuff in UK jurisdiction.
Yeah, absolutely.
And you need to know that that law has been applied to it. So if your storage company moves it out to America without telling you, you have to worry about that.
I think that's a great point. So with my iPhotos, me as an individual, I don't care. You might care. Some people are much more private about their content than others. And there's rules and policies for that. But my point really is, I don't have to know because it's taken care of for me. Now, when you think about it,
But it isn't, because most of the terms and conditions say you're responsible for backing it up.
Yeah.
Sure.
I look at the analogy in a slightly different way, and that is, first off, you come from consistency. I can throw my laptop out of a moving train, stop at the next store, buy another one, log into my cloud storage account, and boom, all my stuff's exactly where it was before. Now, apply that at a global scale as I'm moving from office to office or cloud region to cloud region, cloud provider to cloud provider. That consistency is really what we're talking about. I shouldn't really have to care about that one device. But to your point, there are rules and regulations, guidelines that you do need to follow, and those are where those objectives that we talked about earlier come into play, is being able to then further tap into the awareness of that data set in a globally consistent way and ensure that it goes where you want it to, and more importantly, avoids going where you don't want it to go. And those are totally automated by way of just the way we provision the storage system in the first place.
But just to make before we go into the security bits, just to make it, people often have a hard time grokking what Hammerspace is doing. The key point I want to make here is that concept of access to your files that happens in the consumer space, and most things in enterprise have some ties and follows to consumer space, is essentially what we've done with enterprise data. So that what Brian's talking about of, it doesn't matter which device, which system, which location, you can have access to all your data without making copies, without having to have IP connections to a storage system, all those different pieces. The general experience of enterprise data with Hammerspace is similar to your consumer data on your iPhone or Samsung across those devices. And the other piece that you get out of it is, because it's done through software now, you can add a lot of features. So things like maybe you took a photo 10 years ago, now all of a sudden you have AI search enabled on it. Because there was some metadata, now there's tools to take advantage of it. You get that same thing with enterprise data with Hammerspace too. Because your data is in Hammerspace and we've added a new feature or a new partner to do rich metadata search, all of a sudden you just have that for your data that exists without having to reprocess it, repurpose it, and those types of things. So that's kind of the net experience that you get with your data through orchestration, whether it's in the consumer or the enterprise space. We'll go through a lot of details because you're absolutely right. Who can access it? Where can it sit? How secure is it? There's a lot that needs to be done there. I agree with that completely.
Just one final sort of general question. How granular is your metadata? Because if you're storing something that's called like a customer in a data lake, the terms and conditions attached to that piece of data may differ depending where it comes from,
Right.
and which country it resides in, and which country it relates to. So it's not enough to have metadata by data file. You might want to have metadata by data instance.
So it's funny you use the word instance. So we'll use that a lot today, and you'll hear it over and over again in Hammerspace. We are acutely aware of, at a file level, where are the instances going? And so we can track and guide instances of those files in relation to those regulations as well. So the metadata is applied at a file level and above. We can do that either by way of just inheritance. We can set flags in a namespace and just say anything that manifests under this point inherits these traits. We can apply them programmatically. We've even done some work where we've tapped into applications directly and leverage the way that they interact with data to trigger metadata updates and objectives to drive that placement inside of Hammerspace as well.
That's not true, because for things like consent, I may have given a consent for my data to be used in a PR application.
Mm-hmm.
Somebody else, same piece of data, same data name, may have not given consent. So it's not a case of having consent stored by a particular file type of data.
Right.
The consent has to be stored other
So
purposes.
one thing I would say on that, one of the biggest, I think, opportunities for value with Hammerspace is our ecosystem partnerships. And specifically there in life sciences, a couple of the partners we're talking to are the people who have the SaaS tool for consent on clinical trials, things like that. Which data is public, which isn't, who is consented, who hasn't. We're not going to get involved in that in Hammerspace. What we will do is provide connections to enrich our metadata to have that be a triggerable field. So third-party partner, the consent application is creating metadata, which can trigger objectives. So this type of data can move, can be shared, can be accessed by certain people, not others. So that's what these objective-based policies accomplish. And we have very open standards to enrich our metadata so that the people can do that. We certainly won't try to write all the tools ourselves, but we will work with them to enrich our metadata and then make policies that are appropriate. It's a really good point. It comes up a lot. Because people think, gosh, global access to any data, wow. But you don't want to control that through IP addresses and connections, hardwired connections into a specific storage cluster. We want to handle it more at how is the data being used layer. So it's just up leveling it a bit.
The other thing, I'm sorry, I see your hand. The other thing that I think is important, and it comes up a lot as well when we start talking about providing a global view of all of the data, it's not global by default. We can pick and choose that we use the word site participants. So you think about when we throw out an example of a customer that's got us deployed across 15 sites globally, that doesn't mean necessarily that all 15 sites see all shares and all exports in the same way. You can actually guide the visibility of that namespace differently across those sites. They still get the same benefit globally, but the view that they have of it can be customized a little bit more.
Yeah, forgive me, I'm truly gifted at getting the wrong end of the stick. Right? But what you've been describing in terms of scenarios for Hammerspace seems to me to be exactly the same as BDI. Citrix has been doing this for 1,000,000 years.
Yeah.
So what's the difference? Where is there much of a difference? Where are you better, worse?
So I'll give you maybe a more real world example. I'm working with an opportunity right now where the customer has 8 different points of telemetry capture for an autonomous vehicle program. That view needs to be consistent so that their data scientists see the same thing everywhere and can curate the data in the same way. So in this way, we're giving the same presentation, that same view everywhere. Those users can actually tap into our metadata to customize what should actually be driven back to a core data center for actual training or preservation or choose your reason. Or maybe it's just ejected from the edge and it never needs to go anywhere else. But in that way, now we're not talking about a VDI session that I can move around. I'm actually talking about I've got to offload data from a high throughput, very high density level of data set at an edge location and somehow or another figure out how I either eject it or backhaul it for the next stage of its life cycle. Does that help?
Yeah.
And I think the other thing that in that case, VDI virtual desktop stuff is a part of our distributed workforce conversation. And that is a use case for Hammerspace. But when you think about things like burst for compute, what we're doing is if you think about the complexity of you have data sitting in a couple of different locations. In supercomputing, they use job schedulers for this. They know which data is sitting where and is relevant to the project, and it's okay, it's time to go process that data. The job scheduler invokes the right number of compute and the right amount of data to do that. Well, imagine an environment where you have data sitting in S3, Blob, NetApp, and Pure Storage, just as an example. And you want to render data from that's sitting in each of those different storage systems in a compute instance in Google. I'm just trying to make it super diverse. What we will do is say, okay, we know all these data types and these different locations are associated with each other. It's time to render them. We'll orchestrate them to that Google compute environment because they're the only ones who has available GPUs for your AI job, for example. So there's a lot of things we do other than user desktop, and that user desktop is one of those things. And those virtual desktop companies are partners of ours because they're kind of the last mile. We get the data in as local proximity as possible through local metadata and even potentially placing data where it is closer to the desktop. But they're partners in one of our use cases. But the larger market for us is more about unifying data sets above storage silos and then being able to put it to work because you have unified metadata for the project which you're doing. And I think this will be more clear when we talk about the AI use case, for example.
Yeah.
One request, can you tell us when there is a new slide compared to before? Because some of us have heard the story. So if you can, identify that.
Sure, everything else from here is new.
Yeah, and secondly, if you feel like it's the right time to answer it, we talked about supercomputing and job scheduler. How is that different to what we were doing with Hadoop?
So
5-10 years ago.
So the thing I think about with a job scheduler is think about what the job scheduler's purpose is. It's making sure that I've got enough free resources in my environment to now actually satisfy the scale of which the job needs to run. But those are traditionally looking at things like how many CPU cores do I have or how much memory footprint do I have. The challenge they don't usually take into account is once I release those cores to the scheduler and actually let the job go, now the wait IO starts. So now I have all of these cores that I've gone off and allocated that are now waiting for data to get staged. What we offer now is the ability to tap into that scheduler and make data presentation local to that compute resource one of the things that triggers the release of that batch. Does that make sense?
It does, but why couldn't that have been part of job schedulers' parameters?
It might be definitely location awareness of where the data is, but now you're asking the job scheduler to tap into some shared storage resource across, choose your adventure there, how it's going to interface with them. Part of our goal, and what you'll hear us talk about all today, is there's the unique traits that make Hammerspace a commercial thing, but we've also done an awful lot of work to push a lot of the things that we're doing back up into public standards, open standards rather, and making them something that everybody can use universally.
Thanks.
Sure.
So I want to talk a little bit about an AI reference architecture. So we aren't allowed to talk publicly about who the company is, but one of the largest, most sizable large language models in the hyperscale world is being trained by Hammerspace. This was an environment where they obviously have access to a lot of their own technology, which they write, as well as to, any vendor will do just about anything to get these kinds of environments. I want to talk a little bit about what the environment looked like, and then I'll also talk about why they chose Hammerspace. So in their environment, each of their data centers has 16,000 GPUs in their storage cluster. Those are existing today. Massive compute environment that was already in place. Standard Linux-based servers, as you would expect, with 2,000 clients connecting into their storage systems. Those storage systems, they, in large part, had already bought a lot of storage, and they wanted to be able to take advantage of that investment. If you think about 600 storage nodes, so about 22 petabytes of NVMe, throwing that out, the baby out with the bathwater to go to a new data or storage vendor wasn't the most efficient thing for them. So as they started to look at the technology companies who were available to power this massive GPU compute farm, being able to use their existing storage investment was important to them, and being able to add to it over time, which they'll probably go to a more standards-based storage systems in the future, but being able to use those both were very important. We're getting 60 terabits a second of throughput from the compute to the storage, and you'll notice right here you don't see Hammerspace anywhere. And that's because we are an out-of-band parallel file system, which was also very critical to this customer. That if we were in band as a NAS target, they would never be able to achieve the near 100% utilization of the compute, of the storage, or of the massive amount of networking that they have in place. So being an out-of-band environment was critical. So all of that was in place when Hammerspace came in. We just kind of tucked in on the side. In comes Hammerspace. Now all of a sudden you have out-of-band metadata services, you have a parallel file system client that's being able to deliver the full performance of this infrastructure. So being able to come in and take advantage of everything in place, deliver near 100% performance out of that environment, and go on to be able to use their standards-based deployment of other servers in the future was really important. This was our first deployment, so 60 terabits a second, about 20 petabytes of storage for large language model training. They do have other data centers, and they do plan to now orchestrate as they do continual learning of the large language models. They'll use our orchestration to bring all those data sets together, which no one else could do. So the first thing that they started with was, what's the company will select for a single data center? And oh wow, that same company can orchestrate my other data centers. That's really fabulous. We know they did, so they considered Lustre, and they didn't like that Lustre was not standards-based. They didn't like that Lustre would require a proprietary client on these different servers. And they also didn't like that they didn't have a lot of control of what went into the Lustre standard. They really like that Hammerspace is doing a lot of our work in Linux, which is what Brian's going to talk about. So if they want to contribute into Linux, they can do that too. So they have the ability to influence our technology as well. Yeah, go ahead.
Before we move away from that, if you wouldn't mind going back, the other thing that's not obvious is, it's all fun and games when we talk about speeds and feeds and throughput and all that kind of fun stuff. But the other interesting challenge statement that they laid down is, most storage infrastructures you go into and you start talking about an enterprise class storage array, the question eventually comes in of, well, how do you recover from insert failure here, right? How resilient are you? The challenge statement we got from these guys was, hey, we've got multiple power feeds coming in. You should assume at all times 2/3 of the power is down. That 2/3 of the environment can be offline at any given moment, and you need to perform just as well as you were doing it when it was healthy. That was the gauntlet that they threw down. And that's why what you see here with the 3 Anvil, the 3 metadata servers, there's 3 power rails within this one particular facility, and we are replicating the metadata and the presentation of that file system consistently across all 3.
How much heat do you generate while doing this?
Oh.
How much load do you add to the data center?
In our case, like we say, our portion of this, the Hammerspace portion of it, is a metadata database. Everything else is the stuff that they already had. We added no new infrastructure beyond this environment right here for the metadata server. So I don't know the answer to your question specifically, but I can tell you that the delta from before Hammerspace to after Hammerspace was just those 3 Anvil instances.
Because we embed our clients in their existing servers, we don't bring in much new except for the metadata servers. So you can think about, this is the type of company who writes a lot of their own code and thought, should we build this ourselves or should we license it? They love, like I said, that we do things in standards. We have engineers who sit on site with them and do code development. That was a big piece of what they loved about Hammerspace. There are other companies that you all have heard of and write about, that do high performance file stuff that aren't parallel file systems. They fell over at about 10% into the test plan on their ability to scale. So they looked at everyone. And most of the companies couldn't even come close to meeting the performance scale of what they needed. And we had the efficiency of using the existing infrastructure and hardware. We didn't have to bring in new servers. And we do things in standards that they can influence. So there's a lot of things that we do in this space that makes us very attractive. So we're going into POCs with 2 others right now. So we'll probably see Hammerspace as something of a standard in this space, I would suspect.
And we'll dive into the details on how this works in a little bit.
So data architecture, I want to share a couple more things here that recently we did a webinar with Gary Grider, who is the lab director of Los Alamos National Labs, one of the big, most influential supercomputing sites, but also he's kind of the grandfather of Lustre and Ceph. And when you think about Gary Grider, this is his slide that he put together talking about this was Lustre, this was VAST, and this was Hammerspace. He doesn't like to call out vendor names. We really don't either, but just to give you a feel for who he was talking about. What he sees in his talk track to this is, in HPC sites, we used to have about 5 different file systems. We had some kind of NAS for home directories, enterprise stuff. We had Scratch, distribution, archive. They had all these different purpose-built file systems, 2 of which he is kind of the grandfather of. And when he came across Hammerspace, and he's very close with our CEO, David Flynn, and saw that David had invested personally the resources and money to get NFS 4.2, so what we all used to know of PNFS, but NFS 4.2 done and working, where you can actually use this as an out-of-box client in Linux. That was cool. It finally solved the problem that Gary wanted with NFS that he's been championing for 20 years. But he also said, I never thought it would be possible to have a single file system that could be built into Linux that had the right I/O patterns for throughput, checkpointing, Scratch, metadata ops, that we could get this all in a single file system. And when he and David, and he's one of our, not official advisors, but he's very involved, they write code with us and things like that. When David said, we can do that in Hammerspace, he was like, I don't believe it. So he brought it in-house. We're actually going to be releasing benchmarks coming off of their Trinity supercomputer soon. But he's like, I can actually, at Los Alamos, collapse 5 file systems into one with Hammerspace. And these are not our slides. These are Gary's that he presents to his own industry. You'll see the only yellow we have is on archive. And that's because of our ties to tape. There's a lot of tape in supercomputing. And if you were at the supercomputing show this week, which Brian and I were briefly, we had 2 of our tape partners in the booth with us. And that's something we haven't really announced yet, but we are working on the alliances, and those are in place, and we'll be announcing, publicly soon. But they were in our booth demonstrating our ties to integrating tape into your global data environment. So I think that's worth sharing just to give you a feel for when you're comparing the high performance options out there in the data center, what Hammerspace is doing. And this doesn't really have a lot to do with orchestration. This just has to do with high performance workflows. And then when you want to do data distribution, which is his word, or orchestration or collaboration, just like in the AI case study, that's kind of like the cherry on top of the whipped cream sundae, so to speak. Any questions on this?
Will Hammerspace think about supporting NVIDIA's GPU Direct?
Yeah. So our architecture is totally compliant. We're actually doing the testing right now. The announcement, where it goes up on their website is days away.
Yeah, they have a test that we're running right now. It's in flight. We'll hopefully have the result here. I don't know. I would guess by next week.
Yeah, it wasn't a coding thing. It was a self-certification.
Yeah. They want you to stand up a connection between, you guys may already know this, but for those that don't, they want you to stand up a session between a non-RDMA enabled storage entity, run a baseline, then establish it over an RDMA transport that can light up the GPU Direct side of life, run that test again, and then show a delta. So that test is, actually it may even be done by now. They started it on Monday, and it runs for a little bit of time.
Does this mean that Hammerspace can front-end non-GPU Direct supporting finance, provide GPU Direct context?
We can, actually. And matter of fact, in the previous example that we were showing, all of those GPU nodes, there is no GPU Direct in that environment, and it's not because of us.
And you'll see this in his build. This will be interesting.
Yes?
It is a yes.
Yes, sorry. I also use more words than necessary. Again, Southeast Texas public education.
I'm going to skip past this for a second. I want to go to your slides for a second.
Sure.
Brian, I think that. So I want to talk a little bit via Brian about how this architecture works and kind of how we've been chasing bottlenecks as an industry. And GPU Direct is a step. But maybe I'll hand it over to you to talk about this part.
Yeah, sure. I'm glad she's handing it over. When she said she was going to talk by way of me, I thought we were going to do a ventriloquist.
I was going to pull on your hand.
Yeah. It's going to be fun. So, I think, we'll talk a little bit about some of the forward-looking stuff that we got going on, but, a history lesson's probably worthwhile. We'll try and keep it pretty simple. But if we think about things from a direct attached storage standpoint, you kind of start implementing immediate bottlenecks right out of the gate. An op has to fly, especially for feeding a GPU or an PCIe attached thing. An op's got to fly from that PCIe bus to the CPU down into some kind of, traditionally, if we were talking about normal legacy storage, some kind of a RAID controller that's going to now be the pinch point in that environment. Everybody agree with me so far? All right, sweet. So let's take that guy out. Let's talk about bringing on some NVMe storage in that environment. One of the challenges you run into right away is the RAID controller can be a bottleneck, but we've now moved the storage right onto the PCIe bus. So we've now shifted the bottleneck a little bit more, and it's now up to that CPU side of life. The storage itself can deliver data faster than a lot of CPUs can actually transact the ops. So there's where vendors like NVIDIA come along and start implementing things like GPU Direct. Everybody with us so far? Excellent. So that's fantastic, but that only works for local storage for the most part, or if I'm doing some sort of NVMe over Fabric directly into that box. But what if I want to do shared storage? I mean, in the environment we were talking about before, part of the infrastructure that's being hosted in that 16,000 GPU environment is the home directories of the researchers that are caring for that data. That has to be a shared storage environment. So how do we now remove bottlenecks all the way up to a shared storage environment? Well, first, let's start by identifying what they are. So there's a handful of things that happen underneath the covers. There's things like identifying what physical media is going to be responsible for a specific block address. That's one. Then there's going to be another one that says, well, how do I now map a file ID or portions of a file ID, maybe erasure code shards, something like that, down to a physical block map? Then how do I all turn that into something that represents the actual file system itself, the directory entries, the listing of the files, the attributes, and all that? Right now, in a single direct attached storage environment, all of that lives together. But if we start separating that out to a shared storage environment, there's a lot of builds in this. I need to put timers in them. So you start, but maybe that proves the point. You also start injecting latency along the way, and now all of a sudden we went from what was 3 hops on a direct attached storage, we got it down to 1 hop. Now we just invited 8 more. We've now got 9 potential places where data's got to go flow through in an architecture. We've also now got to distribute some of those layers of mapping to different entities in the environment as well. And this is what we see in traditional NAS vendors today. It's just how it works. So to try and get around that, people started getting super crafty by putting NVMe over Fabric, sometimes by way of open standards, sometimes by way of proprietary clients. But that does reduce some of the transactions down there at the host that owns that storage. Now I've put it back into the PCIe bus and taken it away from the root complex of the CPU itself. So that's cool. Sorry. So that's cool, but what we wanted to do was say, well, let's look at these different layers of how we map stuff and come at it from really a true parallel file system approach and move the presentation of the data itself, for lack of a better word, a data router, off to the side as in a traditional a parallel file system might do, but now still keep that NAS interface, that NFS interface back to a shared storage environment on the back end. And in doing this, we can start leveraging advancements inside of NFS that we're contributing to the open standards, and there's a lot of them that are already out there. You'll hear us talk about things like flex files layout, compound operations in the protocol stack itself, things that we're doing to eliminate the actual round trips that are sort of just accepted as normal. Please.
I hate when people interrupt me, so I'm going to do it to you.
That's all right.
But this build here, in that AI model of why we were able to scale and other companies who were tested were not, is on the performance is because of this. So our performance limits, yes, we scale in capacity too, but our performance limits and the ability to deliver near 100% usage of all of those resources and scale in performance without having to worry about nodes and sizing and all of that is this. So this is like the meat of why in large language model training, we can deliver the performance at scale that those other companies cannot.
Is there any requirement on NICs or the network itself to have a minimum set of standards here?
I mean, we'll go through the normal kind of shared storage infrastructure sizing dialogue with you to make sure we're not bending physics. But otherwise, no. I mean, it runs just fine on my laptop. It doesn't make it the right thing to do, but you can.
And the other piece, we recently were at a company up in Canada talking about the performance of their Isilon system, and this is really interesting. Isilon, they had an old Isilon, I don't know, 6-8 years old, that was performance saturated. They put Hammerspace in front of it, and we're still using the Isilon box, but taking these pieces out of band, and they were able to double the performance of their existing Isilon with no hardware changes by putting Hammerspace in, because again, all this processing is now done out of band, so the storage server can do just data path stuff. It's pretty significant in just using hardware efficiently. Yeah. And if you notice parallel file systems, that's what they do, but you've never had that in NAS before.
Yeah, when we presented this story to the broader team at LAML, one of the guys said, yeah, that you change a couple of your words out and you've just described something that looks an awful lot like Lustre, but has open.
But it's a NAS.
But it's NAS.
Yeah.
So. And we'll dive into more of the details on how we implement this as we go through. But here we go. So that's cool. We've gotten
so Kioxia.
Yeah.
We would love to have an Ethernet SSD that we can put NFS in.
You and I might have a conversation later on. So the idea, let me back up for just 1 second because, by the way, these are new slides. Sorry, forgot to call that out. Sort of new. So the thing that's important to point out here is I may even back up one more time, just to reference what Molly was talking about in that previous test, where the the scale out vendor that was an alternative in this scenario, they bottlenecked around here. What we've done is been able to separate, by separating that out, we took, if you kind of rewind in your mind's eye to that visual we had of those GPUs, this layer with all of their 600 storage servers, that's where those live. Those 3 anvils that were the Hammerspace, that's what lives over here. So in that environment, we're actually just routing the data directly to their already in place NVMe storage servers behind the scenes, and we're not a part of that conversation anymore. We hand back something that's a layout that says it describes where the files are placed in those NVMe endpoints, give that back to the client. The client can now negotiate that session directly over an NFS v3 session, and we are out of the data path. Question? All right. Comment? For your
Like
advice?
DNS for data.
It's what?
DNS for data.
So it's funny you say
Use
that.
term. You're right. It's well done.
It's exactly it. And I'm going to try and parrot our CEO's analogy because he used the same one recently, and you're exactly right. But what's accepted in the storage world? So sorry for those that didn't hear the question, maybe for the recording as well. The statement made in the room is well, that sounds an awful lot like a DNS server. Well,
data.
I'm sorry.
DNS for data.
DNS for data.
Yeah.
Well, but the privilege that a DNS server has is it can say, here's the IP address of the host you just asked, and then it's out of the way. It's not in that conversation anymore. But when we think about any shared storage environment on the planet, in a NAS sense, that they don't get out of the way. They've got to hand back the location of where it is and own in perpetuity that stateful connection to the data, and they've got to be able to scale all of it at the same time. So you're right. We've effectively created a layout router or a traffic cop for, hey, data you asked for lives in these potential places. Go get it. Yeah, good call out.
Can you provide the equivalent of GPU direct, AMD, Intel GPUs?
Ooh, I forget the name of the standard. We can do an RDMA transport. If all they need is an RDMA transport and an OFED driver, I would say yeah. But I don't know that we've tested that yet, so don't let me mislead you. Fair? Did that answer most of your question? I'll take that as a yes. Did I leave anything dangling there that's a...
No,
okay.
I heard everything you said.
Okay, good.
And I take it a lot of this also applies to the DPU concept as well.
So the DPU thing gets interesting. We've mainly from the standpoint of a lot of the services that Hammerspace provides can be offloaded into some of those environments. That's super high. We haven't done any of that. We've done some of that work, but not in super detail yet. So ask me again next year. Anything else you'd say on that?
DPUs come up, and I think they will be relevant, but yeah, I agree.
So now, if we're all comfortable with the idea of the previous example going to their NVMe servers, wouldn't it be super cool if we could just put an NFS-aware SSD on a fabric somewhere, a flash device, an NVMe target, something on a fabric somewhere that instead of having to light up as a target device that's then leveraged behind a file system that lives somewhere else, what if we could just give it awareness of the NFS protocol in the first place and tap directly into it? And now all of a sudden you've got an infinitely scalable environment, as many ports as you can light up on the thing, and start pushing increased throughput with just scaling up your metadata server, your presentation of that data set. And
we're actually running that in our labs. We need an Ethernet attached SSD to be in production from somebody. We actually have some of Kioxia's they've kind of put on the side for now in our labs.
Seagate SSDs.
That are Ethernet attached?
Are they Seagate?
Oh no, they're Kioxia's, but they're Kioxia's. We took them. It's just a project they didn't launch into the market, and we asked them if we could use some of them just to play with it, and they're like, yeah, you can. But that's a SSD vendor conversation of when they'll produce those. But we have the technology that when an Ethernet attached SSD comes out, that we can do this now from the data side.
Can I just pipe up a second, please? If anyone has any questions about the Kioxia side of things, Cameron.
That's why I keep looking at him. He doesn't know about any of this. Like, he's not the person we're talking to, so don't put him in a bad spot.
Cameron, can you please confirm your job title at Kioxia?
I'm part of corporate marketing, but I have ties within the SSD business unit as well as the memory business unit.
I'm not understanding. Are these Kioxia SSDs being used in this?
Yes. But they never brought those fully to market. Yeah, exactly.
They're
so
not available publicly.
Correct. We just wanted to try it, and we knew they had developed some technology, like in beta or whatever they call it. So we asked them if we could borrow them to try it out, and they were agreeable. But that's not a product that's in the market. We're just trying to influence one of the SSD vendors to do it.
This is not under NDA, so we can talk about the concept.
Sure.
And the concept's
just as long as it's clear, Kioxia hasn't released this product, so we're just doing it's lab testing standard stuff that we're doing.
We'll be happy to publicize it.
Other questions? All right. So, hopefully some of the benefits are obvious, and I'm not going to read all these things over to you, but I think where it starts to get super interesting is really about reducing the overall round trip time from requester to satisfaction of that request. We're now optimizing that transport. We've taken it all the way back from what was 9 on a normal shared storage environment, back down to close to what it looked like from a direct attached storage standpoint, but done it in a very nicely scalable way from an NAS standpoint.
Does this mean you could have a Hammerspace server sitting in front of the eSSD JBOF?
Like a Kioxia Kumo scale.
Kumo
Yes.
scale, well, yeah, Kumo scale is no longer.
Is no longer.
Correct.
So to answer your question, we can sit in front of anything that will give us an NFS v3 endpoint.
Yeah.
So if that eSSD is giving us that NFS endpoint, then yeah, it can sit behind our namespace.
So some of it is, you think towards, our founder was the founder of Fusion.io also. He knows SSD stuff well. And we're looking towards, we've been influencing Linux for a long time now in the NFS kernel. We're looking at what is the next step, and the next step as we constantly chase performance capabilities and hardware efficiencies. And that's a logical next step that we pitch regularly at like Storage Developer Conference and places like that, because we want to keep pushing the industry forward. So that's a forward-looking concept that multiple companies will have to rally around to get to, but the data layer is there today.
Yeah, and it's actually an important point to emphasize. I don't think if there's something you take away from this, hopefully it's that so far you've seen nothing proprietary from Hammerspace. This is all open standards. It's all stuff we've contributed back into the kernel. We were looking at it yesterday. I forget how many RFCs we found that were just Hammerspace RFCs presented back into.
Yeah, and some of them are linked into the press release, so
Yeah.
you can take a look at it. But the goal of it is use existing servers, existing hardware, and deliver a lot more performance for your files. So you can do all of this at scale. And these are the kinds of things we need to do to accomplish that in a enterprise environment.
Yeah, I mean, you don't get to, one of the challenges that you've had all along, and why I think you've not seen the prevalence of NFS v4.2 so far, is just so up to the last few years, you've had so much complexity from the client standpoint. You had multiple Unix flavors, you had multiple Linux flavors, you had different people doing different things in different ways, and you had to try and accommodate for all of them. But at this point, I think we would all agree that Linux is probably the winner, right? And in that way, since we've been contributing all of this right back into the Linux kernel anyway, given our relationships and our history there, now it just gives us a place now where we can really focus on that one approach through a Linux kernel, implement everything we need to from a client-facing standpoint, and then start backing in all of the things we need on a server to complete the rest of that conversation. We are now taking some of the dialogue in NFS from a stateless client-server relationship to a stateful bidirectional conversation, where we're actually able to give ownership to the client of certain traits of that data flow, and even offload some of those things from what is traditionally owned by a storage system. There's some things that are coming later, but today there's things like the client can actually tell us where they would like to mirror the data. We can say, oh, you'd like a primary copy of your data located here and another copy somewhere else, and the client can guide us in that behavior. And that's all just standard.
So you've got the better inherent RAS.
Say that, I'm sorry?
You've got better inherent RAS there. Have you done any qualification of that, what it actually means in terms of the prior environment, in terms of availability, resiliency, and when you're in, because that is one of the top desired outcomes in terms of what we call the most digitally transformed companies, is improving their resilience and reliability. So
yeah,
numbers there.
So numbers, yeah, I don't know that we have, I don't know even how we would start quantifying some of those numbers. I'll go back to the statement we made earlier around that other large scale customer. A lot of companies are not going to be able to come up here and tell you they're going to stand just fine when 2/3 of the infrastructure is down. So we made that possible in what we're doing, and we've done it just by simply actually leveraging some of the objectives that we have in the system and that client side awareness to be able to say, here's your awareness of your 3 fault domains, send the data across those fault domains as part of your primary portion of that lifecycle. But you can also shift that mid-flow and say, as data demotes in its lifecycle or evolves in its lifecycle, you can elevate or demote that protection scheme as well. So it's not going to be a constant fixed number that is just a thing for Hammerspace. It'll actually be guided by the objectives you implement and the infrastructure that goes with it.
And if you think about one of the things the objectives do, we support anybody's storage underneath us. So we have environments with Cloudian, we have environments with NetApp, Vast, whatever. And those objectives can also say, okay, these are the storage targets which I have, and I want to accomplish a certain resiliency. Okay, put that in object storage. I want to accomplish a certain latency. Put that in NVMe storage. And so our objectives will choose from the available storage, whether it's just white box storage or a branded storage, where data sits to meet those objectives. And as you all know, each of those vendors have different RAS ratings and whatnot too. So
when we define, I think maybe this is another way to potentially complete the picture. When we define any of these storage volumes in the system, and we refer to them as volumes. When we define these volumes, we will apply a few traits to that definition. Those traits, in an automated way, will be a performance threshold. Like, what do we actually experience from our point of view against that storage volume? We will log that as a trait of that volume. An admin can come in behind us and apply things like a monetary value, an availability, this is 5 nines capable tier of storage or a volume. This is a 11 nines durability tier, capable tier. And those all just become traits that persist with that volume at that site. Now those traits become inputs to an objective, and I can say, given, in relation to the lifecycle, all the stuff we were talking about before, but I can actually say the data in this moment in time, its value warrants this level of performance or this level of durability, and that becomes now part of that orchestration.
And so we'll take more questions, but just kind of a guidance. Let's move to kind of what the proprietary bit is.
Yeah.
So now that people understand, there is another question.
Okay.
But I think we want to shift towards, okay, that's standards-based stuff that we've done, and then talk a little bit about the Hammerspace bit that plugs in.
Absolutely.
Let's take the question
Take the
first.
question, though.
Sorry.
You're good.
Maybe a silly question, but you talk about open standards, but people interpret standards differently, and two things may not interoperate, even if they both follow an open standard. So how do you handle certification that things that you're talking to do actually interpret the standard in the same way you do? Does that make sense?
It does, and we'll cover some of that when we go through this. It'll maybe be a little bit more obvious, but maybe to sort of plant the seed. Think about it from the standpoint of there's a portion of the conversation that the clients will execute with us, and that'll happen over PNFS. And then in almost a kind of, in my home, I'm sure this is a fairly common phenomenon for all of you guys, but the kids will come and ask me a question and I'll say, go ask your mother. And they've got to ask the question of their mother the right way to get the right answer. So my kids know how to get the answer out of me and they know how to get it out of mom. And so in the same way, what we've done is made it so that our kids, the clients, understand how to communicate with me, dad, at the Hammerspace side of life. And when they go to talk to mom, they're doing that over legacy NFS v3. So that is tried and true. We know how all that works. I understand the v4.2 conversation. As long as my kids understand that and they've been taught that by way of implementations in the Linux kernel, then we're good, and I can just tell them, go ask mom.
Does it ever go wrong? I mean, do you ever have problems with finding that what somebody wants to do that should work doesn't quite work?
No, never.
I think
Because you told them to ask mom, come on.
I think the one place where we find, you have to size and have performance, and that's what these technical folks do.
Yeah.
One of the things that we do with these existing storage environments is we assimilate the metadata into Hammerspace. And that metadata assimilation, so you have NetApp, Isilon, and something in the cloud, we have to make sure we actually can assimilate the metadata, and everybody has little proprietary bits of how they write metadata. And that's the typical place where, maybe there's been a code change in some, off version of some NAS we haven't seen in 4 years or something, and we have to look at that. That's usually where the bumps come from. They're solvable.
Yeah.
And for modern, latest and greatest stuff, it just works. But I would say that's usually the
That's
place.
usually what it is, or you run into, different people have treated mixed mode permissions different ways over the years, and so being able to understand how we're supposed to go in and treat those things as well. When you add those volumes, that whole volume conversation we were having, when you add those to the system, you can define who the vendor is, and if there are things that we need to look out for that we know about that we've tested, then that is invoked when you define that volume and its type, its brand.
Sounds to me there's a requirement for your customers to have good configuration management, what they've got, where it is, and so on. And some firms, or quite a lot of people, don't do that any longer, or they do it just sort of casually.
Sure.
And it seems to me if you're going to put it all together into a data lake, you'd better get the maturity of your own metadata handling up there fairly quickly.
Yeah, no, well, and it's, so as Molly said, we've had the product in a GA state for the last 3 years-ish. Two. Engineering's been happening for a long time before that to make sure that we got that right, because yeah, that the smarts in that metadata tier, yeah, you're right, it has to be spot on. We've got to make sure that that's ultra resilient.
And then the rest of the compatibility, that's why we do a lot in standards based. Like the NFS 4.2 client, we needed something called Flex Files, which enables all these orchestration and really taking advantage of that. We just contribute it to Linux. Everything we do, we're contributing as much as possible. So if you want this architecture, as long as your Linux clients are Red Hat 7 or above, it just works. You know, so that's a lot of it too, is just knowing the latest standard operating systems can do most of this, and that helps a lot with, it's not co-development of other things, it's just if you have a Linux box umbrella 7 or above, it just works.
Just works. I like it. So, any other questions?
And it's already there. It's not that it just works, it's already there.
Right, it's been there for a while.
We need to move.
Yeah, I'm going to speed this up a tiny bit. Please keep the questions coming, but I'm going to start talking a lot faster. So this should look a lot very familiar from the previous drawing in terms of data flow. But what we've done now is, in this case, we're just establishing a communication from what we call our Anvil. So for those of you that don't know Hammerspace lingo, Anvil is what we call the metadata server that we take out of that, out of the path of the rest of the communication dialogue with the client. One thing what Molly just said is this Flex Files thing is a thing that we've committed back into the kernel that allows the client to ask, where does my data live? It's the DNS lookup equivalent of your data. Where does my data live? That data is now fanned out today at a file level. We can place a single file in a volume. We can have the next file right next to it in the namespace at another location on another volume elsewhere. We can do that client-side mirroring phenomenon that I was talking about, but you can kind of use your imagination and think about where that might go later on as well. The really cool part about that is I might have a single handshake session from a client to my Anvil, but I can hand back multiple locations in my layout and actually establish parallel data paths to multiple backends behind the scenes. And that parallel connection can happen over traditional TCP. It can do it over RDMA. We've also started leveraging things like NConnect. If you're not familiar with NConnect, think about what a traditional single stream transport might be bound by the latency of a TCP stack. NConnect lets me spin up multiple concurrent streams from that client back into that server environment as well. So we can kind of overcome latency with streams, with parallelism. So that's all built into that environment as well. Again, just to make sure I'm clear on this though, this is providing the ability to query the metadata and then get out of the way. And this is what that other customer was using to achieve the throughput they were with those NVMe storage systems. Now, there's another component we haven't talked a whole lot about with Hammerspace today. This is where we start getting into some of the magic that we do inside of our offering specifically. And that is, there's another component that lives adjacent to that Anvil. It's called the DSX, the data storage node, and it has a few functions. And those functions can be portable. We can offload them and isolate them as well in this environment. It's something we work with the customers on. You'll notice that this was not in the previous drawing of that large-scale customer. They are using some of this logic in other places, but they didn't need a dedicated set of these services. In any case.
And I just want to say something there. So people often ask us, well, I mean, like when I talk to analysts who are sizing markets, they're like, well, couldn't you be just in the storage NAS market? Of course we can. And we do have that technology. And yes, you could just deploy us as an enterprise NAS. And we have all the features. And, you know, sure, we could get a feature war. But yes, absolutely. That's just not the innovation at Hammerspace. So we don't focus on it. And the reason you don't hear us talking about, you know, this magic quadrant or that storage vendor versus us. And, you know, I mean, we certainly watch what they're doing because we can use their environments as part of our global data environment, but the innovation is all these other pieces. But that said, there are customers who say, can't you just provide me with storage yourself? I don't already have it. I'm building out a new environment. Yes, absolutely we can. It's efficient and has lots of enterprise data services. That is part of Hammerspace. But we focus our time with you all and with our customers because the innovation is these other pieces that we've been talking about.
Yeah, and I think, jumping out of tech mode for a second, just thinking about go-to-market, there were questions around channel and engagement and all that kind of stuff. One of the other things that makes the engagement with the channel community super powerful with what we're doing with Hammerspace is, yeah, we can be the storage tier, like Molly just said. But if I'm a channel partner, if I'm anybody that's walked into an environment that just made a decision on pick some other storage vendor, I don't want to walk in and tell you that to get the value of Hammerspace, you've got to throw that away. So yeah, we can provide the persistent storage. If that's the route you'd like to go, we can enable that. But we also want to let you leverage the resources that you have. I mean, the Isilon environment Molly referenced earlier was 6 years old, something like that. They've got an aging storage device that we just gave new life to. And so
and that's also why our sales cycle is 9 to 14 months. We're still figuring it out because we're new. We'll use storage that already exists, and we don't have to wait till it's end of life or the next big storage procurement cycle. They'll add Hammerspace in because we're largely just software.
Yeah, so that's a good segue. So we are, it is just software. To get your hands on Hammerspace goodness, you're going to get an ISO or an OVA. If you're in a cloud provider, you'll get an ARM template or a AMI or however you go about your deployment, your vessel that you'd like to put it on. You can choose bare metal, VM, pick your cloud provider. So you can go that route to get the software up and running. Molly referenced earlier a process that we use called assimilation. I don't think we have a slide on that in here. So just to cover that, it's not just that there's Star Trek fans in the company, but assimilation actually means it's a process that we use to peek into an existing file server, take the metadata that they are using today to represent a file system, and elevate it into our Anvil. And now all of a sudden we've effectively made a copy of all of their old metadata into the Anvil and give all of the value that comes with all of the standard stuff we've presented, all of the stuff that we're doing in our layer. We give that ability now to this old storage tier without migrating any of the data at all. The time to value in that conversation is minutes. Literally from the second we light up Hammerspace, we can point it at an existing NAS and kick off this assimilation, and within a few minutes you can route your clients through us and get that value right out of the gate.
And the other piece that it adds, which this metadata presentation that's very active and immediate, is if a data move, we don't need to move data, we'll just leave it in place. But if data is going to move for any number of reasons, you're making a copy, you want another region, whatever, you want local to compute like we were talking about earlier, that data while it's moving is accessible while it's in flight, so you don't have to worry about, oh, it took me a long time to move it, even though we have some acceleration partners to help with that. You can keep working with that data in flight because you're working with the metadata. So there's a lot of things that are done here because of our metadata awareness that have immediate time to value, use the data if it's being moved, consistency, and all those pieces that's really valuable. And customers, when you say, why would I bring in Hammerspace? When I already have made my storage purchases, they bring it in because they need to use their data elsewhere for other projects, and they don't have the technology to do it. Plop in some Hammerspace software and you're doing it tomorrow without an infrastructure change. And it's really powerful.
It's very cool.
Yeah.
So I said I was going to speed up and then I didn't.
Yeah. 15 minutes. I saw her sign.
Yeah, they're already playing the Julia Roberts Get Him Off the Stage music. So, the store function, one of the three functions a DSX node can provide. And again, if you're kind of rewinding in your mind's eye that architecture we showed earlier with the 600 NVMe nodes in there, they are effectively acting as the store function themselves. So in that world, we didn't need to deploy 600 store nodes in the Hammerspace world. That's what you get out of those. Another function within a DSX node is that cloud mover functionality. So think of it, a lot of people just call it a data mover. In this world, it's really all about, again, a bare metal, VM, cloud, we don't care, choose your own adventure on how you're going to deploy it. We'll help you size it the right way, but this will be specific to that data placement. The result of the objectives that you implement are going to be driven by how we scale these guys out. And this is where all of that assimilation happens, all of the placement of multiple instances of files, et cetera, all happen inside of this cloud mover. In the data mobility or data movement engine. Then the third trait of a DSX node is a portal mode. Portal mode allows us to satisfy legacy file connections. This goes back partially to your question earlier about, we've got all these new standards, but if people haven't adopted that yet, how do we help everyone else? Well, that's where the portal mode comes in. Portal lets us serve legacy NFSv3, SMB2, 3, CSI, S3. So we can hand out all these other protocols from the DSX layer and have effectively the DSX server be the protocol server for all those legacy protocols. But inside the DSX node, it is now a constituent of the Anvils and leverages the same open standards communication back and forth inside the cluster as well. So in effect, we're not only the Hair Club president, but also a client. Nobody got that joke? Sorry, it must be a US thing.
I don't think hair clubs in.
So
we go to proper barbers.
So then we elevate this out a tiny bit more. We've talked about this as being an ISO or an OVA, but what if we could start containerizing these services and placing them in different places in the environment and orchestrating the placement of the services in relation to the orchestration and placement of the data itself. So there's a lot that goes on here, and I'm going to kind of skip past this because there's one point I want to make on this. So now what can also start to happen with this is if I put that container instance actually on the compute node, think something that looks similar to like a hyperconverged thing, but the idea that I can take this logic of a DSX node and put it on a compute node directly and be able to now serve data directly to that, I can even make the client aware of the fact that it owns an instance of a file in its own box without having to go back over the network to go get it again. Right? So now I deliver the scalability of NAS, the consistency of a global namespace, but the performance of a local block store. Kind of cool. All right, so anyway, now how do we do this at a scale? Super quickly, we've talked about these components as if they were in a single place. When we start scaling this out to multiple facilities, multiple sites, whatever word we want to use, we will stand up another environment that consists of those same things, another set of Anvils, another set of DSX nodes. There's no requirement for symmetry. We can deploy them in an asymmetrical form. We can do it, we can have different cloud providers, different cloud regions. We can have different, on-prem site. It doesn't matter. We'll work with you on what those things look like. And one of the reasons they can be asymmetrical is, like I said before, we can make the presentation of that namespace unique to that site as well. So I can make it all global. I can make it partially global. I can isolate portions of it as well. The way that we do that is when we instantiate another site or a participant, you'll see it if you ever look into the Hammerspace documentation or UI, we'll call it a participant. When we establish that participant relationship, we effectively establish a point-to-point replication of the metadata only. So in this case, a user creates a new file on one side, that is pushed out within a few seconds to the other site participants' Anvils in that namespace. Data mobility happens when we inspect that Anvil. One of the traits of the Anvil is where in the world is that data set today. The data set the most current version of the data set, I should say, it might live locally right next to the requester. It might live at another site. The Anvil knows where that data is and can trigger the action that goes and stages the data to the correct site in relation to the requester.
And one thing I want to mention here, this is a subtlety that just I want to draw attention to. This is not just a namespace. This is a read-write parallel global file system that you're connecting to. So all the data in all these systems, as people are working on it, this is an active file system. This is the master file system. It's not a catalog that knows where data sits. It's not a read-only thing that says, okay, I have 3 clusters and this data is in this one, this data is in this one. This is an active file system that is referencing data stored in all these different places. So this move that's happening with a lot of the space towards more ability to catalog, query metadata, have global namespaces is moving in a direction at the storage system level. But Hammerspace is elevating across any vendor, any cloud, active read-write. So it's not just a catalog. So one of the vendors, some of you may be familiar with Starfish, who is Jacob Farmer's company in the US. They do really interesting work with metadata cataloging where you can search and query. They'll connect Starfish into this parallel file system to give even more robust life sciences querying of the catalogs while we're the active data environment. And so I'm highlighting that because sometimes people don't catch that this is actually a file system that's spanning across. It's not just a catalog or a namespace or something else.
Yeah.
And that it changes how people think about Hammerspace quite a bit.
It's an important call out too. I stumble on it a lot when I'm talking with customers and partners about it because to your point, right, they'll think since we're still leveraging their last year's storage purchase, they sort of don't really think about us in the right way. To try and clarify that a tiny bit, I think of, if you take away different vendor names and just think about different tiers of storage, those might get presented over different transports. right? It might be this is an NVMe transport, this might be a SATA transport, whatever it is. Well, now think about that, but that could be a Cumulo, it could be a NetApp, it could be a VAST, it could be. We are the owner of the file system. They own the transport to the data layer. So,
Sorry, so any complexity with deletion, or is it just the same as any other update?
So it will be the same as an update. There's a little nuance in that we need another hour and a half to go talk about. So I'm happy to talk with you about it at some point. But that is the idea too, is if we're all global in the same spirit of assume some portion of the environment's down, we should also assume that a site's down. And so the short answer here is yeah, they are all aware of each other, but we are all about each site first and then the global portion of that second. We will prioritize operations at a site level and then eventually in an eventual consistency model, make sure that the rest of the namespace is the same state.
Now, eventual consistency worries me a little bit because sometimes you need to have limits on how long it takes to get consistency.
So we will continue to persist changes in the namespace for however long that outage exists, and as long as you have resources on site to deal with them. And then as soon as everything comes back to life, we'll reestablish that connection, synchronize those changes globally, and then we can start leveraging things like previous versions of files, undelete rules, those kinds of things to make sure that even if data was deleted elsewhere, while the site was offline, that we're protecting it in the right way so that when it all comes back to life, we can get the data if we need to again as well.
But there might be some opportunities for arbitraging differences between a site that's offline and a site that's connected.
So you'll see it in the UI. You'll also see it when those files come back to life, when we resynchronize. If we happen to have like a collision in the namespace, say somebody created the same file on two different sides, but they weren't able to tell each other about it, we will persist the versions of those files that are presented relative to the site that created them. So you'll see both of them, but the current version of the file from site 1 will be the one that site 1 wrote, and then they'll see site 2's version string sitting right next to it. So you'll actually, in this case, if they're disconnected but ops continue on both sides, we'll persist both of them and worry about how to figure it out once everything comes back.
That can be policy driven. Can you put a value, a status on whether site 1 or site 2 is more important?
Maybe. I'd have to think about how we would apply that one. Yeah.
So as we wrap up, there's just a couple other things I want to make a quick comment on. So this is one of our customers. This is Blue Origin that we talked about earlier. They have NAS systems, third-party vendor branded NAS systems in each of these data centers. When they were looking at how are we going to start to collaborate on our research, we have launch data, we have failure analysis, we have telemetry data, whatever it is. We need a real-time active file system that has access to all this data. It's not referencing data that's stored in one place. They're actively doing processing, collaboration. They have compute in different places. They thought they were going to have to build this themselves. When they found Hammerspace, they were delighted because they didn't have to. And so that's one of the really interesting things here is they are using us to orchestrate data to remote compute environments. They're using us to do real-time collaboration. Absolutely, I would imagine they'll be using us in some sort of AI where they're loading this into Gen AI models. And that's all what the magic is of this orchestration and doing it in an active parallel file system that spans all of their sites. And this has been in production now for a year or so. It's not a new customer, but I think it highlights the use case of active data across sites managed by a single file system. These slides are all going to be sent to you. I bulleted it out, some of the things we do competitively, if it helps you, that will be in your deck. But the last thing I wanted to talk about is a little bit about cloud AI models, Snowflake, Databricks, and some of our partners on that side. So these two companies have different objectives with their analytics capabilities. Snowflake wants to get all the data into Snowflake Cloud. Databricks wants to expand to the data center. So two different companies, two different business models. Both of them are partners of Hammerspace. And what they're looking at is they've done a great job with structured data, but as we all know, 95% of the world's data is unstructured, and they want that too, especially as you're thinking about Gen AI. And Hammerspace is one of the key tools to do that. So on the Snowflake side, there's all this data that sits outside of Snowflake Cloud that you can assimilate into Hammerspace. And when it's time to run an analytics job in a Snowflake, they can reference and say, okay, here's the data we need. we are going to move it because we want the data in Snowflake Cloud, and we'll do the move of the data up into Snowflake Cloud. But if it's not all the data, that's okay. It's done intelligently and selectively based on which data needs to be moved for the job that you're doing in Snowflake. On the Databricks side, they want to expand where they will reference Hammerspace and leave the data in place in the data center, but now they have access to, through all their Delta Lake technologies and everything else, the metadata we have about existing data in the data center. So you don't have to go and find it, you don't have to copy it, you don't have to figure out how to make Databricks aware of it, because you just make Databricks aware of our metadata in the data center. And so when we think about the play for Hammerspace, a lot of it is data exists today. Let's make sure we can catalog it into a single metadata server and then use it with the compute, the AI, the models, whatever it is, wherever they sit. And so Hammerspace can be a standard data access point for these different use cases. And so we don't have a strong opinion if data stays in the data center or if it moves. We don't care. We make a lot of intelligence around what is the metadata, and then if you want to make it accessible to other tools and applications, we make it easy to do. So we see these kinds of partnerships as, very exciting in the AI space. Training large language models is very exciting, but there's a million of AI vendors and data analytics vendors who need access to both existing and new data. And if you think about that whole ETL process of a data scientist, extract, transform, load, you don't have to do most of that because your data is all in a single data environment. And so if any of you listen to my podcast, I talk to data scientists a lot who are using Hammerspace, and they talk about how much simpler their ETL is, or ELT. They say now it's ELT, and now they say with Hammerspace, I don't even have that at all. And this is all data science talk, but we make it where you don't have to go find, move, replace, copy, manage data sets because you're using one data set. And then if it transforms, it's still in that data set and doing it all in a single environment. So it's really transforming the data science workload in a very significant way for these types of environments. Given that this is kind of a storage-focused, A3 is a storage PR agency, we wanted to focus a bit today about the storage innovations we've been doing, but I did want to tie up with it's really the AI models, the data analytics tools, the upstream applications that are becoming more efficient by having access to big unstructured data sets that aren't in a data lake. We give them structure so data scientists can use them in normal data science workloads. And so where they used to only have access to a small set of structured data, which they'd transformed, now they have access to all of this data through Hammerspace. And that's where our biggest growth is coming from right now. And that is it, Fred.
Oh gosh, well done.
How much is left in the deck that you didn't get? Never mind.
No, I just was going to talk about customers. There was a question about markets and customers. That was the only thing we didn't touch on. We started out fairly vertically focused, as I mentioned earlier, focusing through COVID, the environments that came out of COVID with a lot of remote workers trying to collaborate. We are very good at that. That's a very interesting use case of you're doing visual effects, color correction in a film, and two flame artists are remote from each other and can collaborate real time. That's been a big effective part of our market, but these bigger enterprise customers doing big analytics and HPC types of workloads, things like the Gen Z or the French exasales project, and that's going on right now, and they're trying to figure out how do we connect 3 different HPC centers across France and unify the data across them. That's just a much bigger opportunity, and that's where we're focused these days. But to give you a feel, we're kind of scattered across universities, HPC sites, media and entertainment, autonomous vehicles, healthcare. We don't have really a core vertical anymore. We're just more focusing on our ideal customer profile has distributed data sets in multiple locations that they need to actively use for research, innovation, and analytics. And I said to somebody recently, maybe one of you in this room, who's your ICP? I said, any company with multiple sites and a lot of data that needs to be used. Yeah. And they're like, okay, that's everyone, So it is a pretty horizontal play now.
Yeah, the vocabulary will change, but yeah.
Could I ask about the channel? Thanks for all the information at the beginning of the presentation, very helpful for me. Approximately, could you give me a ballpark figure of how many partners in EMEA you expect to have this time next year? You said there was 15 in the UK already. About across EMEA, what approximate ballpark figure would you expect?
I'd be making it up if I gave it to you.
Just make it up, yeah.
800 million.
It won't be hundreds and hundreds. We want to find partners who have the skill sets, the vertical focus, and differentiation. So if we have 50 in the UK, let's say maybe it's 30 in Europe right now, maybe we'll double that. We're not trying to do this massive approach.
Big customers don't need so many partners.
Partners who want to add a data layer, they have an AI practice. There's some partners who really have an AI practice today and are putting us in place. So it's really the ones who have the ability to understand and architect and deliver what we do, and the customers who need it. Some resellers don't want a workflow orchestration system. They want a box. They're box pushers, and that's not demeaning. It just is. It's like I have salespeople who are going to sell this capacity, this performance, and put a box in. This is more of an architectural play, and some resellers love that, some don't. And so we're picking the ones that are, really focused on architectures versus selling, like a box. Right. Also. Yes.
If I was an obnoxious storage vendor, is there any way I could block out Hammerspace from controlling my storage?
As long as you're presenting S3 or NFS, no. Some storage vendors want to be our partners, like Pure Storage is a really good partner. They bring us opportunities very regularly because there's stuff in our software which FlashBlade doesn't do. And they love that they're still selling their hardware. There's other vendors who, at a corporate level, are like, Hammerspace, keep them out. And the customers still use us because it's just NFS that they're presenting, and the customer wants us for something that storage system doesn't do, and it just works. So even though we don't have a symbiotic corporate relationship, the customers have still deployed it, and it just works. This metadata assimilation that we do, if they wanted to be tricky and hide and not document their metadata, that would probably be the way in. But that's pretty core in their products to just block us.
They would have to.
It's hard to imagine them doing that.
We look just like an NFS client or an S3 client to the storage device. So they would have to go really far out of their way to block us out.
Yeah, but there are those pieces that a lot of companies in the storage space like us because it helps them when they're moving into an environment. Maybe there's a legacy architecture and they use us to, you have Isilon and you're moving to NetApp, whatever it is. Assimilate the metadata, attach your users to our parallel file system, and as you're implementing the new storage system, that's agnostic to the users. So you can do a migration over time without any application downtime. There's a lot of things that storage vendors like about us.
Oh, no, I understand.
But there's also places where they say, well, you're taking some of the value out of my software because you're putting your file system in. We find the field likes us a lot because it helps them stay in RFPs and deals where they don't have a feature set that they could participate in a deal. And so, the Pure Storage field loves us because they can participate in new opportunities. But maybe their developers are like, that's a little bit competitive. So it's an interesting landscape. We would like to see them all be partners. They don't all see us that way, so that's okay.
We have better friends than others. The one thing Molly said, just to double down on it, and then I promise I'll shut up, is the idea that we also don't have to own the entirety of that other storage thing really behind us.
Yeah.
Right, so it might be that Pure brings us into an opportunity because one portion of a workflow demands what we deliver, and they're going to carve out a small section of a FlashBlade and give it to us. Meanwhile, the rest of the stuff they've been using, whatever it is, I don't mean to keep pointing out a vendor, but whatever they have, they can continue using it for whatever value they get out of that vendor directly, and just light up a portion of that storage for us to use and deliver our value.
And we see that in NetApp a lot. We have built our enterprise on NetApp. We don't want to move off of it. Everything works. We're not going to screw with it. But we do have this research data set that we want to be able to collaborate on. Great, just move that research data set to Hammerspace and don't muck with all your users, for example,
right.
That kind of thing. Please.
Do you work more with Pure FlashBlade engagements and FlashArray?
Yeah, mostly because they always are reorganizing and those kinds of things, but that was their file team. And so when they were looking at unstructured data in file, they would often pull us in because there would be something on the file workload that they didn't do. So it was mostly for that reason. It doesn't mean that we can't work with all their block storage. It's just their file storage team and unstructured data teams were in the kinds of opportunities Hammerspace is in. So there was more synergies there on selling.
If we have time, one more question. You just used the word move into Hammerspace. But yet we're hearing you guys are completely transparent.
The metadata is assimilated into Hammerspace.
Sorry,
data stays in place as long as the customer wants it to.
Okay.
Just to be super clear.
Okay, thank you.